All right, let's get right into it. We're all seeing AI do some pretty mind-blowing stuff, right? But have you ever stopped to wonder how it actually gets what we're saying? I don't just mean the words we type, but the meaning behind them? Well, the secret is this special kind of digital brain, and that's exactly what we're going to break down.
I mean, think about it for a second. If you go search your computer for compact car, it's going to find files with exactly those words. But what if you were thinking small automobile or maybe city vehicle? How in the world does a machine figure out that you mean the same thing? You know, solving that puzzle, that's really at the core of what makes modern AI tick.
So for the longest time, we've been using what are called traditional databases. And look, they're super powerful for what they do. But they basically work like a super organized but very literal filing cabinet. You can tell it, hey, get me the file called Sales Report Q3, and boom, you've got it. But if you try to ask for, say, that report about last summer's numbers, forget it. It's just totally lost. It's all about exact matches, zero understanding of context.
In that limitation, it became a massive roadblock once AI started getting, well, smarter. See, AI doesn't think in rigid file names. It thinks in ideas, in concepts, in how things relate to each other. It was clear that it needed a totally new kind of memory to work with.
And this really shows you the huge shift we're talking about. We're moving away from that old-school keyword search, the super literal way of doing things, and into this world of contextual search. And that's the new approach that lets an AI see compact car and city vehicle and go, aha, these belong to the same family of ideas. Okay, so the big question is, how do you even build a database that can think in concepts? The answer is this really groundbreaking technology called a vector database. It was designed from the ground up to do one thing: search not just for words, but for the actual meaning behind them.
So, at its heart, a vector database is all about handling data based on its semantic meaning. What does that mean? It doesn't just save the words in a sentence or the pixels in a picture. No, it stores the essence, the very core idea of what that data is all about and how it connects to everything else.
The real game changer here is how they store information. Your traditional databases use those neat and tidy rows and columns. Vector databases, they do something completely different. They take data, text, images, whatever, and turn it into this long string of numbers called a vector. You can think of this vector as a kind of mathematical fingerprint for the data's meaning. It's basically the Rosetta Stone for AI, translating our human concepts into a language that machines can actually work with.
Now, I know this might be sounding a little complex, but the central idea is actually pretty elegant, pretty simple. It all comes down to something called similarity search.
It basically works in three main steps. First, an AI model grabs your data. Let's say it's a sentence or a photo, and turns it into one of those numerical vectors we talked about. Step two, it plots that vector in this enormous, high-dimensional space. The best way to picture it is like a giant star map, but instead of stars, you have concepts. And things with similar meanings, like king and queen, they naturally group together. They form little clusters. Then, for the third step, when you make a search, the database isn't looking for a perfect match anymore. Instead, it's just looking for the nearest neighbors to your search query, and that's how it gives you the most relevant, context-aware results.
And this is what makes it so real, right? The words car and vehicle are spelled differently, but their meaning is almost identical. So their vector representations wind up being super close neighbors in that huge conceptual space. That's the magic right there.
Now, the engine that makes this all happen at lightning speed is an algorithm called Approximate Nearest Neighbor, or ANN for short. And there's a good reason for the approximate part. I mean, trying to search through billions of data points for the one perfect match, that would just take forever. So ANN is smart about it. It's designed to find a good enough match almost instantly. And that speed is what makes things like real-time chatbots even possible.
So you can see this isn't just some abstract futuristic idea. This technology is actually the invisible backbone that's powering a ton of the AI tools you probably use every single day, maybe without even realizing it.
It's the tech that lets large language models pull in fresh, up-to-date info. That's a process called RAG. It's the secret sauce in search engines that actually understand what you mean, not just what you type. It's how your favorite streaming service seems to know exactly what show you want to watch next. And this is a big one. It's what gives AI chatbots a long-term memory, so they can actually remember the conversation you were having 5 minutes ago.
Okay, so why is this specific type of database such a big deal? Well, when you're talking about building serious, real-world AI applications, the advantages here are frankly non-negotiable.
So, you might hear about a simpler tool called a vector index, and that's fine, but a true vector database is built for the messy, chaotic real world. It's designed to scale up to massive sizes, to handle data that's constantly changing, and to let you actually manage your data properly. You know, the basics: creating, reading, updating, deleting. Plus, it lets you do smart filtering with metadata. Think about searching for summer dresses, but then filtering to only show the ones that are actually in stock. Those are the kind of features that take you from a cool little prototype to a powerful production-ready AI app.
And really, that brings us to the most important point of all. This isn't just about a better way to store stuff. It's an enabling technology. Vector databases are what give AI the power to understand context and relationships. And without that fundamental ability, the sophisticated chatbots, the amazing generative AI, the smart search systems we're all using today, they just wouldn't be possible, plain and simple. So as we finish up here, I want to leave you with this thought. We have now built the foundational memory for an intelligence that can actually understand meaning. So now that that crucial piece of the puzzle is in place, what does that really unlock for the future of artificial intelligence? Where do we even go from here?